So I like programming in C for a lot of different reasons, but one of the biggest ones is that C is really consistent. In general, in all cases but one, there is one simple set of rules in the language, and the rules are always followed, which is great because we learn about ints, we learn about doubles, we learn about things like pointers or loops or functions, and we know that the rules always hold. So for example, I can create a pointer to any type. I can make an array of any type. What kind of code can I put inside a loop? I can put any code I want. There's no weird arbitrary set of rules to learn about when you can do something. In general, there's one rule and it always holds. And that's great. There is, however, one exception, and it's sort of a big one. And it's what happens if we pass an array to a function. Now, to be fair, it turns out this isn't so much of an exception to the rules as it is a very strange way that the rules get applied. I know that's I'm sort of weaseling out of responsibility there, but it turns out there is sort of a justification for this, and we'll see the justification next week. So the key thing here is when you pass an array into a function, something a little bit unusual happens, and we need to know how to work around that. So what I've written here is a piece of code that creates an array, and then it prints the array out, and then eventually I'm going to call a function here, and then it prints the array out again. And you might recognize this type of code as something we've seen a lot before the midterm. That demonstration that when you pass a variable to the function gets a copy. It doesn't get to modify your original. So contrast that, for example, with this situation here. Int x equals 6. I call a function f and I hand it x. I don't hand it a pointer to x. I hand it my original variable x, and then I print out the value of x. We know already this is a trick question. The value of x here is going to be 6. Period. The function f has no right to modify my original because all it gets is a photocopy. It doesn't even know where the original is. Okay, so here's the array version of that problem. I print the array out once, I call the function, I print the array out again. Let's try doing that without calling the function. And predictably, it prints the same thing out twice. Now let's uncomment this. And we'll go up and take a look at our function. So here's my function here, and then in the brackets I'm giving my argument as being an array of 5 elements. And one thing you'll notice is that in this iteration of the course we're very careful to, when we specify that a function takes an array as an argument and we know its size, we should put the size in there. And also, if the array happens to have a variable size, you might do something like this. So if I don't know how big the array is going to be, because it could be any array you give me, then I'll take a value n, which tells me the size of the array, and then I'll encode that into the type of my array parameter. And that means n has to come in as the first parameter, so that when you get to writing int a bracket n, the compiler knows what n is. Okay, so there's that. I'm taking the array as a parameter, and then I'm calling the function on this array here. And the function, of course, attempts to modify the contents of its argument. And we know already, in the version of this based on regular variables like int x, we know that the function is only modifying its own copy. But unfortunately, that's not what happens with arrays. We can see that here. I ran the function, I gave it my array, and when the function returned, the original array had been modified. So just like before with 2D arrays, there's a short answer and a long answer. The short answer, which I think is not satisfying at all, and honestly just makes things more confusing if you try and think too carefully about it, the short answer is when you pass an array to a function, the function is getting your original. And that means that the function modifies that argument, it is modifying the original array. So we don't make a photocopy when we do this. That's the short answer. I hate that answer because that implies that the rules aren't being followed. The rules are, in C, when you pass something into a function, the function doesn't get the original, it gets a photocopy. So it's really unsatisfying. It's frustrating to be told, oh no, when you pass an array, the rules don't apply. It turns out that the rules do apply. It's just a question of when I pass an array, what am I really passing? So for all intents and purposes, for the first week or so of using arrays, it's sufficient to remember that when you pass an array to a function, you are not making a copy. The function can modify the original. We need that. In the next video, we're going to see some exercises involving arrays where that's a really big deal. But you also deserve the long answer. You deserve to know the truth. And we're going to spend time expounding on this a bit more in a week, but I need to give you at least a version of this today. Let's trace this. So here's my function main. Draw ourselves a nice big scoping box. Now I'm going to do a sort of half-assed trace here. I'm not going to trace this entire loop. I just want to make sure we have enough to illustrate the problem that we're dealing with here. So I get into main and I create this thing called my array. And my array is an integer array of 5 elements. All right, so I've been drawing my arrays on the diagram in this strange way, and that's deliberate. That was actually foreshadowing this issue. So when I draw my array on my diagram, I draw it as a sort of pointer-like thing. And you might notice that unlike a lot of the diagrams I draw involving pointers, this is not in a box. And that's significant. What I'm trying to indicate there is that my array the name myArray is a way of referring to the first element of this array. But unlike a typical pointer, you can't change it. You're not allowed to make this point to something else. It is forever locked to point to the first element of this block of integers here. Okay, but what that means is that if I ask you, what is my array? When I use that name, what is it? Actually, what it is this arrow. And if I use square brackets, the square brackets imply follow the arrow and use the result. And that means if I call a function, so here's literally called a function, the function takes as its argument, it's going to be called a. What the function actually gets in its variable a, and it actually does put it in a box, although this we will worry about in greater detail next week. What it actually gets is a copy of this. So the value of my array, the thing I passed in, is an arrow pointing at the beginning of this big block. And that's all that gets passed in. So the value a inside the function is just a pointer back to the original array in main. Now, the reason this is important to me is that this is actually a bit convoluted. I mean, we are still wondering, why aren't the rules being fully followed here? Why is this the one case where the variable secretly corresponds to an arrow? This is something we'll unpack next week. It has to do with the intimate connection between arrays and pointers. What's important to me for today is that the rule about what gets passed in is being followed. The thing the function receives is a photocopy. It just happens to be a photocopy of an arrow, not a photocopy of a huge block of stuff. And deep down, one of the reasons for this is that if my array had 1,000,000 things in it, I wouldn't want to make a photocopy of 1,000,000 things. Although you could argue still that should be the programmer's decision. But fundamentally, it's because the array itself, the name of the variable, just refers to the beginning of the array. It's an arrow. So when I pass that in, I am passing a photocopy. I'm passing a photocopy of an arrow pointing at the original array. And it turns out that that has a lot of implications. One thing we're going to see next week is that for the same reason, it's impossible to return an array from a function, because the actual storage for the array is always property of the original function. If you return the array, you're just returning an arrow that points at one of your personal belongings, but the function, if it ends, will destroy that. So we see that the typical way that we work with arrays and functions in C is that we create the array. If a function is supposed to produce an array as its result, we create the array first before we call the function, and the function gets a pointer to the original array and then fills it in. So we'll see that a bit in the next video. The key thing to understand for now is that when you call a function and just pass in the name of an array, the function is getting a pointer to the original array. So you are not making a copy, so you do have to make sure you can trust that the function won't destroy what's in there.